Cheerios tumble into the bowl with that familiar little rattle. Cold milk pours in, and the rings float golden, light, barely spinning. You have poured them for your kids before school more mornings than you can count. They feel like the easiest breakfast in America. But pause on one tiny ring for a second. It is made from oats, a grain that wants to become soft, heavy, dense. Touch it with water, and it turns to paste. Everything a Cheerio has to be the grain resists. That O was not gently shaped. It was blown open from the inside by a pressure cannon, a process closer to firing a gun than making breakfast. This is how one stubborn grain became the cereal ring sitting in your bowl. By the early 1940s, corn already had cornflakes and wheat had Wheaties. Both grains cooperated with the factory. They could be flaked, toasted, puffed without a fight. Oats were the stubborn sibling. Cook them and they collapse into porridge. Dry them and they crumble apart. No one had ever turned oats into a cold cereal you could pour from a box. General Mills brought in Lester Borchardt, not a chef, but a physicist. His team studied puffing technology, seal steam inside a grain, release the pressure in one violent instant, and force it to expand from within. Alexander Anderson had demonstrated the concept at the 1904 World's Fair by firing rice from a brass cannon, but doing it with oats at factory scale in a consistent ring shape millions of times a day that had never been done. Borchardt's team cracked it. They called their creation Cheerios. It hit shelves in 1941. Then something else happened. Quaker Oats pushed back, insisting no other company could put oats on a cereal box. By 1945, Cheerios quietly became Cheerios, a name born from a trademark concession, not branding genius. The name was settled. The real challenge was not. Every morning, the factory still had to turn a grain that wants to become paste into millions of identical rings, each one light enough to float and soft enough for a baby to gum. Here is the thing nobody tells you. At factory scale, turning oats into that ring in your bowl is not a recipe. It is a physics problem, and it starts with destruction. Whole oats arrive at the mill looking nothing like breakfast. Small, tough, tan-colored grains still wrapped in a papery husk. Steel rollers crush them into flour so fine it looks like pale dust. Workers blend this flour with water, sugar, salt, and a starch modifier until it becomes a dough heavy, dense, wet. Press your hand into it, and it feels like thick modeling clay. Nothing about this moment says cereal. Now the shaping begins. The dough enters an extruder, a machine that forces this dense mass through a steel plate drilled with dozens of tiny ring-shaped holes. A spinning blade slices each ring free, thousands per minute, each one cut to the same diameter and wall thickness. Pick one up at this stage, and you would not recognize it. The rings are wet, rubbery, and heavy. Drop one in milk and it sinks straight to the bottom. So how does that rubber washer become the thing floating in your bowl right now? This is where the gun comes in. The puffing gun is a sealed pressure chamber. Wet rings go in, the chamber heats. Moisture trapped inside each ring becomes superheated steam, pushed past its boiling point but unable to escape. Pressure builds. Then the chamber opens instantly. The pressure drops to atmospheric pressure in a fraction of a second, and the steam inside each ring has nowhere to go but outward. It expands violently, blowing the ring open from the inside, making it hollow, making it light. This is not baking. This is a pressure release so fast that the grain's own water becomes the engine that reshapes it. Anderson fired rice from a cannon to prove the concept. General Mills adapted it for oats. By the 60s, batch guns gave way to continuous puffing systems. The principle has never changed. Trap water inside starch. Heat it under pressure, release instantly. The grain does the rest. After puffing, the rings travel through toasting ovens at around 140 degrees Celsius. This is where the golden color develops and that toasted oat smell hits the one you recognize the instant you crack open a fresh box. Then optical sorting, where high-speed cameras photograph every ring and air jets blast away any that are cracked, fused, or misshapen. Honey Nut gets a glaze, Original gets nothing, just the naked toasted ring. All of that exists to do one thing: make a ring light enough for a toddler to pick up and strong enough to survive 3 minutes in cold milk. You have watched cornflakes go soggy. Pour the milk, answer one text, and by the time you look down, the flakes are drooping, soft, half dissolved. A flake absorbs liquid across its entire flat surface with nowhere to hide. A Cheerio lets milk pass cleanly through the center hole without saturating the walls. That is geometry doing what no coating can. The shape solved another problem no one at General Mills planned for. Cheerios became America's default first finger food because the ring checks every box, no sharp edges, fits a pincer grip, firm on a wet hand, soft enough to gum without choking. No other cereal shape hits all four at once. That was an accident of engineering, not a design brief. Here is where the story flips. You hand Cheerios to your toddler because they feel safe. But in 2009, the FDA sent General Mills a warning letter not about contamination, but about the words on the box. Oats contain beta-glucan, a soluble fiber that can reduce cholesterol. The FDA allows that as a qualified health claim. But General Mills pushed further, promising specific reduction percentages within specific timeframes. The FDA said the packaging was functioning as labeling for an unapproved drug. A cereal trusted enough for a 1-year-old had its box compared to an unlicensed pharmaceutical. General Mills adjusted the wording. The yellow box stayed, but the line it crossed is still there, on every food label, promising health outcomes in clinical terms.
They're manning 8 of them, and we're looking for consistency and good product. So they are under a lot of pressure to make sure that they're flipping those at the right time and shooting them at the right time. I just found that really fascinating.
Next time you pick up a box, look at one thing most people skip. Some conventional oat farms use glyphosate, not to kill weeds, but as a pre-harvest desiccant, sprayed on the crop days before cutting to dry it faster for mechanical harvest. Independent testing has found residues in finished Cheerios. The EPA says those levels fall within approved safety limits. What within limits means when the product is in your toddler's hand every morning is a question the label does not answer for you. Now pull back further. General Mills has reported soft demand for traditional cereal. Fiber used to sell the box. Now it is protein. Cheerios protein already sits on the shelf. The aisle is being reshaped by consumers who expect a gram count from every meal. Zoom out and you see 3 eras. Cheerios was first sold as Oats made convenient, then Oats made me heart healthy. Now Oats are made protein relevant. The ring has barely changed in 80 years. What changed is what America needs breakfast to do. A dry rattle in a bowl, rings in cold milk, light enough for a child's hand, shot from a pressure cannon, renamed after a lawsuit, and still on your counter come morning. That is the process. We reveal how things actually work, one story at a time. If there is something you would like us to explore next, let us know. Until then, trust the process.